very long time till here the circuit was like the way it is, right? So that means what, it was already in the steady state. Okay, but at t equals to 0, when you switch on the circuit, okay, then you have to like, it will be a transient case where the t, now you have, the circuit will be having some current or the voltage, whatever you want to calculate it as corresponding to like as the transient case, right? But there is also a steady state when the t will again go to the infinite, right? Because again the t will go to infinite, whatever the storing element that you have, dynamic element, whether it will be charging or discharging, it will go till t equals to infinite. So if it is charging, then it will go like the like the uh, it will store in the form of some current, and the capacitor then it is in the form of like basically charge, but use all, basically we call it as a in the form of a voltage, right? So the high the voltage will go, so generally happens it will be in the form of some charge if it is charging, and if it is discharging it will go something like that, right? And this is a normal, this is a standard case, and if it is a normal case, then maybe some initial value will be there, then the charging will happen something like that, right? From here it will charge, right? Or if it is discharging it will go like this, something like that, correct? So this all things is clear. So T0 minus T0 plus is just after you switch on, and this is just a minus the switching on the circuit. So at T equals to 0 minus, this is also one of the steady state, right? So if this is one of the steady state, then you can use the properties, like you already know the properties, because see here for the dynamic element you need the values of 0 minus, right? If it is an inductor, you need like what is the current through that inductor at 0 minus, because that the same current will be there at 0 plus also, correct? And if you are transforming in the inductor case also, you need that, like if you are using the Laplace method also, there also you need the initial condition, correct? Because you already know that, right? What is the, how do you calculate the inductor, like C what LDI by dt, right? It is voltage, right? And if you have to calculate, then that will comes, or maybe you can just think of as like it is v equals to LDI by dt. And if you want to use your Laplace transform, right? So if you want to calculate the Laplace transform, I already told you, if it is in the form of differentiation, something get multiplied, right? S will get multiplied, and then if you have the initial condition something given, then there will be other values also, correct? LI. Okay, so that's why you need the initial conditions. You basically need the what was the current, like I'm just talking about inductor first. So if you are dealing with a circuit where only the inductor is there, you need the initial I value, right? What was the I that was flowing through that inductor, because that will impact. Because if there is a no initial condition, then it was pretty simple, right? You can directly transform your circuit, whatever the inductor was there, directly as an impedance of SL, right? But if there was a current flowing through that inductor before, like at T0 minus, at the another steady state, right? Then you need this value also. You have to like, how do you transform if you have an inductor, something like that? L. How do you transform at steady, not steady state? Steady state, you already know, you directly short circuit that. But what? How generally you do transform in S domain? If there is some current I already, then how do you write it? How do you transform in S domain? That you already know, right? Or you don't know? Anyone? If you have an initial, some initial condition of current, like some initial current is already flowing through that inductor, like at 0 minus there was some current that was flowing, so how do you write? Because if this was 0, then you can directly write it, right? But if it's for not 0, then you transform, right? Well, with inductor, you add one voltage source also, right?
Yes, sir.
Correct? You write it a voltage source also, that is like L of I0 minus, correct? And this becomes SL. And this, how we are getting this? This Vs, V. How we are getting? I told you, right? V is what? L di by dt, correct? If you have L di by dt, the same you do, right? SL minus Li 0 minus. If you have an initial condition, if it was 0, if the current was 0, okay. Let's say example, there is a question that you can think of. See, there was at t equals to 0, we switch off the circuit, like switch on the circuit, okay. So it goes like this. This is 20 volt. Now, any current, let's say this is I1 and this is I2. Okay. So now, if you have to analyze the circuit at t equals to 0 minus, how will you analyze the circuit? So is there any current I2? Is I2, right? So if let's say at t equals to 0
Yes.
minus, the circuit was open, right? So your circuit is something like that, right? So you just have a inductor and two resistance, right? There is no any source, right? Current source or voltage source. So the current will be 0, correct? So the current I2 will be 0, right? At what? 0 minus. That means what? There is no any current that was flowing just before the circuit was open, right? If just before the circuit, and it opposes, like generally the properties of the inductor, it opposes the change in current or change in energy. Basically, this is change in energy, and you already know that the energy formula for the inductor, right? Half Li square, right? So it generally opposes the change in energy, whether it's a capacitor or an inductor. So what happens in the case of inductor is the energy that you write it in the form of Li square, right? Something like that. Okay, so this is 0 minus equals to half L I0 plus A square, correct? So this get cancelled. So I of 0 minus equals to I2 of 0. Similarly, in the same case happens in the capacitor. So there will be half CV square that you write, correct? So there also the same thing happens. So here, that's why the current, it generally opposes the change in the current, and the current before and after is same. Okay, so the same thing happens here. If you see that, and now if we'll just connect it to t equals to 0, now whenever you will transform, so let's transform this equation. So you already know that this current, in this current through this inductor, just before the switching, like just before the switching case, right? So the current was 0. Okay, so now you can if you will do the transformation, you not no need to add any voltage source or anything, right? Because the current was 0, right? So you can directly change it like something like that. So this will become whatever the voltage source. So 20 by S, this 5, this 5, and then this will be 2, so 2S, correct? And if you have to find
That
anything, you can find it.
the
Yeah,
that is 10 ohms, the upper one.
okay, that is 10 ohm. Okay, 10 ohm. So if you have to find, when asked to find anything, you can find, because these are in the parallel. This is in the, sorry, this is in the series and this is parallel. So 10 plus 2 and 5 parallel, correct? And then 20 upon 7 S is the voltage, You can use the voltage divider rule to use calculate I1 and I2 both. And then whatever the equation that you'll be getting, let's for example, if you have to find I1, what will be the equation?
20 by S divide 5.
So it will be what? 4 by S.
Yes, sir.
Correct? So if you will take the inverse, so IT will be what?
4.
4 UT, right?
Yes, sir.
Similarly, if you have to calculate the I2 also you can calculate it in similar way.
20 by S upon 2S plus 10.
No, no. So this is how you wrote 20 upon S by 5. What is this 5?
5 ohm
No, but
resist.
this you are calculating current, right?
So we can do it by KCL, right? If we take it 0 in ground and then 28 will go to the upside
Okay,
down.
you are talking about the I1. Correct, correct. Similarly, I2 you can calculate, right?
Yes,
I2 is, what will be the equation for I2 is?
20 by S upon 10 plus 2S.
20 by S. What was that? 10 plus 2S. Correct. So this also you can calculate it. This will be what? So 20 by S, and then you have 2 common S plus 5. So this will be 10. So you'll be left with 10 upon S into S plus 5. Correct? And then you can split it, right?
So
Yeah, so you'll be left with something. You can write it in the form of
10
K upon S plus, right? So A and B you can calculate it. So your equations will be something in the form of AUT plus B e to the power minus 5t or something like that. Okay, so this will be the equation of I2t. And AB you already know that how to calculate AB. So okay, how many of you have gone through the lectures of week 5? I guess you have not gone through the lectures. Huh? But it was same, like fourth week and fifth week was almost same. There's not much change. Only the switching condition came, and for the switching condition, there's not much concept that you should be knowing. Only that it opposes the change in current for the inductor case and change in voltage for the capacitor case, and everything else is same. Only if you have been asked to calculate for the steady state, you already know that in the steady state what happens, the for the inductor will get converted to a open circuit and the capacitor will get converted to a open circuit. And why does that happen? I hope that also you must be aware of that.
Yes, sir.
Yeah. See, okay, so you calculate the through the inductor. If I'll talk about the inductor, what happens? Voltage is L di by dt, right? And if it is a charging case, let's for example it is a charging case, what happens? I will keep on increasing, right? And then I will reach to maximum value. So I at t equals to infinite will be some maximum value, and maximum value is some constant, right?
Yes, sir.
So when you will calculate voltage at t equals to infinite, it will be L d of some constant value, right, by dt. So this will be 0. So voltage at t equals to infinite is 0. So directly you can change the inductor to a short circuit at t equals to 0 minus or t equals to infinite. You can directly change it to short circuit because both of them are steady state, right?
Yes, sir. Sir,
Yeah.
in the lecture, I didn't get it how professor changed it in current source and voltage source.
current source, that the volt, like source transformation, right? Any thing that is there in the, like, let's say example, you are talking about the capacitor case,
Yes, sir. In
right? There was
capacitor,
a so if you have a current source, right, in a parallel to a capacitor, you can change it to like this, right, with a
not
voltage
this one.
source.
In
No.
last lecture, professor changed it lap uh, inductor into like current source.
Your voice is not clear, but okay, I'll just see what he has done in the last lecture. See, when you are dealing, I guess you're talking about. See what happens in the inductor case. I was talking about. See, maybe your doubt will get clarified. What happens when you deal with the transient case? Transient case. See, this is the simple approach that we do for a, if this switching condition has been given, and then if you are dealing with just an inductor, okay. So what happens? This all things will happen, and first you deal whatever the circuit that has been given, you deal with t equals to 0 minus, and this is a steady state, because from infinite time to till 0 minus there was one switching condition, like maybe it was open or closed. At t equals to 0 there was change in the condition, this is the transition, okay. And at t equals to 0 plus, again now the transient condition will start. So at this 0 minus 0 plus, some of the values, if you are dealing with the inductor, the current will be same. But at 0 plus, what happens when you convert, like when at 0 plus, when you are writing your inductor, right, maybe inductor you can change it with a current source directly. So at 0 plus you can change the inductor, whatever the inductor has given, directly to a current source, okay. And that current source value will be what, the initial value of the current, okay. Maybe one question will clarify, I guess this is what you were asking, how can you change that.
Yes,
So
sir.
at yeah, so t plus, at just after the switching condition, you can directly change your inductor to a current source just after that, okay. Because there is
Okay.
only, yeah, because there was only this I current that was passing, so you can just change it into a current source, okay. Many a times what happens, people will say like it will be open, because when you have the current equals to 0, when you don't have any initial condition, it will be open. So it's better to call always as a, you are changing your inductor source to current source, but many a times the current itself will be 0, so you can directly open it, okay. And in the capacitor what happens, you sort, if you don't have any initial condition, you directly sort that. Okay, so maybe with the questions it will help you, but this type of questions has not been dealt here. There is no question as such that like needs this much of thing. But yeah, because what happens now, if let's say example you are dealing, so this is a transient condition. If you are not solving with the help of the this Laplace, if you are using the Laplace method now, you don't have to uh, get confused with this case. Like you just, for the transient case, what you do directly from the circuit, like for the time domain you go to the S domain and you write it. That takes care of everything. The Laplace generally takes care of everything, you don't have to think this much, okay. This is when you are using the other method, the transient method. And that, what is that method? I generally you write it as I infinite something plus I zero minus I infinite time e to the power minus tau t by tau, and the time tau is the time constant, okay, t. So this is another method that has not been taught, so you just have to use the Laplace every time, and Laplace takes care of everything.
Okay, sir.
Yeah. See, one example is there. I'll write it out. Maybe you try to solve it out. That will help to have a more clarity. It just have an inductor here. So let's say example. This is a voltage source. So at t equals to 0, what happens? The switch S is moving from a position of A to B. Now you have to calculate I of t, and I of t is for the current basically through the inductor. How will you calculate this?
I didn't know this type of question solving.
What at t? So first you have to analyze at what you have to check, right? Was there any current through this inductor or not, right? For to know whether to regarding the initial condition, right? Because see, for any dynamic element like a capacitor and inductor, the past generally affect the present. Okay, so the past value, the current through this inductor will affect the current or whatever value that you want to calculate in the present also. Okay, so the past value you have to calculate. So you have to calculate the I of 0 minus. Okay, because that will be the 0 plus
It will
also.
be zero.
That will be 0. So at t, so at t equals to 0 minus, what is the circuit? How will you represent the circuit? The circuit
Hmm.
will be something like that, right?
Yes. There is okay. Okay.
What? There will be some current, right?
Yes, sir.
And current of I equals to 0 minus will be what? V upon
A upon R
R.
plus L.
Correct? Okay, one
Yes.
more thing. I told you, right? In the steady state, what happens? A steady state, the inductor will change to short circuit, right?
Yes, sir.
Correct? So here also it will be short circuit. Anybody has any confusion why this is a steady state? T minus or infinite plus, because this is from, like, see, this was already at A for a very large time, right? We don't know when this switch was, like, this the connection was through A, we don't know. So from minus infinite times till 0 minus, it was in the same condition, right? So that means what, this inductor will keep on charging, right? Because this was connected to some voltage source, so it will keep on charging, and it will get charged, full charged, right? So it will be having some initial condition, so there will be for sure this will store charge, right, in the form of phi, right? So that means current, so it will be having some initial current, right, for sure. So that's why I of 0 minus is V by R. So that's why we can change this inductor to a short circuit, because I told you, right, V is what, at V equals to infinite, what happens, this will be I will be maximum. Here for our case, this is from minus infinite till 0 minus, so this is also some form of a steady state only, right? So it takes some infinite time from minus infinite to go to 0 minus, so this is also a steady state, right? So at that time also the current will be maximum, or that is a constant, and voltage will be 0. So that's why I can directly convert at 0 minus, I can directly change inductor from inductor, you can replace inductor with a short circuit, right? And you can calculate of I of 0 minus. Is it clear?
Yes, sir.
It's clear, right? So I of 0 minus, you know. Now at t equals to 0, what happens, it gets connected towards B. That means what, now it will start discharging, right? So now the connection will be something like that. And then we have this is the inductor, and what is that, L, and this is R, correct? And here we can use the transform method to calculate. So this is for what, t equals to 0, or you can say the present. You can use here, see, here you can use any method, maybe differential method, or any method you want to use it, you can use it. Is it clear?
Yes.
Right, okay. So I want to use the Laplace wala method. So how will I do? So now I know that initial condition, there is some initial condition, right? So now if I'll change it to a Laplace domain, so how will I change? This will get changed to a resistance R with the inductor with what? A voltage source, right? Correct?
Yes, sir.
Minus
L
plus,
I 0 minus.
correct? This is how, and what will be the value? This will be SL, right? And
Yes,
this
sir.
will be what?
L I
Look,
0 minus.
correct. Li 0 minus, correct? And this will be, so you can think of this will be some voltage. So I now, I can be calculated, right? Now you can calculate I, right? So this,
Yes, sir.
just close it out. You can write the equation and calculate, right? So let's, for example, this is IS. So plus minus plus minus. So you can write it as
L I 0
IS,
minus upon R plus SN.
correct. SL times IS minus LI. Li0 was what? L equals to LV by R, right? So LV by R equals to 0. So this equation will be IS R plus SL equals to LV by R. IS will be LV by R upon R plus SL. Correct? So you can now calculate the IT from here. Take the inverse. So this will be what? If you just divide everything with L, it will be R by L plus S. So this will be IS, and if you have to calculate IT, this will be what? V by R will be constant, and then e to the power minus uh, T times R by L. Correct? So this is the current. Is it clear to everyone? This question is clear, right? This was having some initial condition. So first, what we have tried to do, and see, and I told you, right, this we didn't use. Why we didn't use? Because the Laplace transform takes care of that. So what we, only one thing that you have to do if you are using the Laplace wala method, what you have to do, you have to calculate the current through that inductor. If you are dealing, if only inductor is there, right? So you have to take care of that value, the current, the initial, because this inductor will change, like oppose the change in energy, right? And basically the change in current. So whatever the value of the current was there at 0 minus, that you have to calculate, because the present will affect the past value of the current, right? So as we have calculated the current at 0 minus, what will you do? You just think of as this is also one of the steady state only. Okay, so at the steady state you can directly change the inductor to a short circuit, and you can calculate the current through that inductor, like that wire or that circuit where the inductor was present, right? So that will be the current. Now we have the 0 minus. If you have a 0 minus, now as the switching changes, now from whatever the circuit that you have, you can convert that circuit to a S domain. And if that, as in our case there was some initial condition, so what I did, I have changed that the inductor with a voltage source, that you already know how to change from transform, that we have got from the transform ka equation, like when we were calculating the transform for an inductor and for a capacitor, we know that that inductor will get changed like this. If you have to convert that to a Laplace transform, then a voltage source will also get added, right? So now we have added the voltage source because there was an initial condition, and now we have wrote the equation, or like KVL KCL you can use. Here we have used KVL, and then you can calculate the current through that. This is what type of questions will be asking. Okay, is this clear to everyone?
Yes,
Anybody
sir.
has any doubt in this? Okay.
Yes, sir.
Okay. So,
So can you solve one question of capacitor?
huh, yeah, let's solve one question of capacitor also. Okay. So for the capacitor, what happens if you have to say, if let's for example there is a case that has been given to you. There was a capacitor. Okay, see, VC has been given to you, and if you have to let's for example, there is some initial condition has been already given. So initial condition is already given. Then how do you convert that? You convert that something like that, right? If this is C, if there is current already there, ICT, like this plus minus. Then in the if you transform it, how do you transform? There is a capacitor C,
And the
and then there
voltage.
is a voltage source. Correct? The voltage source can be directly Vc0 minus upon S.
Yes, sir.
Correct, and this is there is a reason behind that also. See, when you calculate the like how do you, what is the equation? C dv by dt for current, right? If you have to calculate the voltage, how do you calculate the voltage? Dv equals to I by C dt, right? You integrate it.
Yes, sir.
Correct. So when you integrate it from minus infinite to infinite, so till minus infinite to 0, if there is some initial already some values is there, so you split it like minus infinite to 0, and then you split it from 0 minus basically, and then from 0 to infinite. Correct. From minus infinite to, this is a one of the steady state, right? So here you can directly change this to what initial condition that you have. Correct, because there will be some voltage across, that is 0 minus, right? And then the other part will be what? This is what? I upon C dt, like
Yes.
I C whatever this dt, right? So from 0 to infinite, this in the form of this value, right? Now this is V, and if let's say example you want to write it in the form of a Laplace transform, how do you write? So this is what? VCS, this plus 0 to infinite I upon C dt. If you have to write it in the form of Laplace transform, how do you write? This will be Vc 0 minus upon S, correct? Plus whatever
Yes.
the IC it has been given upon Cs, correct? So this is what you convert. So from capacitor that has been given already, you write it in this form. So this will be 1 upon Cs, and then there will be a voltage source, correct? Plus minus Vc 0 minus upon S. Correct. This is how you transform for a capacitor.
Okay,
Okay,
sir.
so that's only one. So when you were having the inductor, the polarity was changed, right? The polarity was minus plus. This was minus plus. Why this was minus plus? Because when you different, like in the Laplace, when you differentiate, you basically minus of like initial condition was happening, right? Correct. See, in the inductor, what was happening? We were having L di by dt. Correct. So when you were writing the voltage in that Laplace transform, it was happening something like that: Ls minus of Li 0 minus. Correct. So that's why the polarity was minus plus. But here you can see that the voltage is what? Here the integrator came, right? So there hit the, you can see that both are positive, so the polarity will be plus minus only. Okay, if the current is passing something like that. So if you just want to write the voltage, just use the like loop minus of VCS equals to what? IC times 1 upon CS, like basically VC and plus VC 0 minus S. Correct? So that's why the you can just think of as for the capacitor, the polarity for the voltage source that you're writing will be plus minus only. So the current that is coming will go from a positive to negative, but for the inductor that was opposite because of the transformation that we were doing, because of the formula, right? Minus. So that's why the polarity was minus plus. Is it making sense?
Yes, sir.
Okay. So now, if we have any questions, Any questions are there from the? Okay, let me check on the portal if there is any question.
So I think there was question in activity 5.4.
5.4. Okay. Okay, which question? 5.4.
Your battery, please.
Oh, okay, okay. So, okay. So 5.4, which question you want me to solve? To see the first question that is there, that is pretty simple, right? This is just a voltage source has been given 10 volt, and then the switching condition has been given, and a resistance is there, and then a inductor is there, and then you have been asked to calculate IT, correct? And this is given at t equals to 0, the switch is closed. So, and you already know that at t equals to, if you want to analyze at t 0 minus, there won't be any current, right? So there is no initial condition.
Yes, sir.
So if there is no initial condition, this becomes very simple, right? You directly connect it, then your circuit will change into 10 by S. There will be a voltage source, and then you have a resistance, and then inductor. So this is a 5, and then this is 10S. Correct? You can calculate whatever you want to calculate. If you have to calculate I, pretty simple, right? 10 upon 10S upon 5 upon 10. Right?
Yes, sir.
Yeah. 5 upon 10S. So this is the first case. Second case, second example, you have to calculate. The second question is also same, like you have to calculate the I, so you can calculate IT. IS first question was there, and IT, so you can take the inverse of that. Okay. Similarly, the second question was, you were having some connection, some voltage source was there, 10 volt, and then you have been given this is 1, and this is 0, and then you have a voltage. So here it is 2. So it has been given something like that, 0.5 Henry. This is 10 ohm, and this is the IT. IT, correct? We have been asked in the circuit shown below, the switch has been opened, has been in position 1 for a long time. Okay, so it was at 1 for a long time. So 0 minus you can just think of as this condition only, right? You can just think of as there is nothing here. At 0 minus, this is t equals to 0 minus, it was connected to 1 only for a long time. The switch is moved from 1 to 2. Okay, so now the switch is moved from 1 to 2. Okay, so here there was, so this is 2. So at t equals to 0, it has moved here. So first what you have to do, for anything I told you, right, you have to calculate the other steady state at t equals to 0 minus. So for any case, for inductor or capacitor, you have to calculate 0 minus case first. For this case, if you have to calculate 0 minus, what will happen? What will be the current? Can somebody tell me? At t equals to 0 minus, what will be the current I value? At t equals to 0 minus, you have to think that the switching was at 1, that was not connected to 2. So at the switching was at 1, so there is only one voltage source, one resistance, one inductor, but the inductor will get changed to what? Short circuit, right? You already know that, because from minus infinite times till 0 minus, this is an infinite time, right? So till infinite time, that means what? 10 volt would have charged, like this inductor would have been charged totally, right? Correct? So there
Yes,
will
sir.
be some current, right? So there will be some current through this inductor. So there will be for sure 1 I of 0 minus.
1 ampere.
Okay. Now, yeah, 10 upon 10, 1 ampere. Correct. So I of 0 minus, you already know that is equal to 1 ampere. Okay. Now it has been changed to 2. So now here it is 50 volt. Correct. Now this circuit will change, right? So something like that, 50 by S, and then you have 10 volt, 10, then you have the inductor, and then you will be having something also, L of I 0 minus. So this is SL, right? 0.5 S. You can calculate the I now. correct? And whatever you will be getting, you can calculate the inverse to calculate the IT. Is it making sense? So this is also simple, right? You just have to calculate the I of 0 minus, like the initial condition,
Okay, sir.
right? Similarly, the fourth case is also same. Even the fifth case is also same. Like there is nothing much, only the inductor. Apart from this, so what happens in the fifth question? The same condition, whatever the voltage that has been given to you, 50 volt, and then 1 is there, 2 is there. The only thing has 50 volt, and then you have, this is apart from any voltage source, it is a simple short circuit. So at t equals to 0, this switch has been went here. So I again, you can calculate, I again will be 1 ampere because 50 volt, 50 ohm, right? And this is 2 Henry. So now at t equals to 0, what will happen? T equals to 0, this will just be having, this will start. So first it charged, as it was connected to 50 volt, the inductor started charging, right? So 50 volt, and now at t equals to 0, what will happen? This will start discharge. Okay, so this is 2. Again, if you want to write it in the form of S domain, nothing, just a, so this will be 50, this will be 2s, and here you will be having Li of 0 minus. Correct? And then you can write the equation of I again. So now, firstly, the equation was getting charged. Now it will start discharging. You can get an idea. See, if you have to calculate IT now, right? So you can get an idea of the equation. How will you get? Now you know that now this is discharging, right? So if this is discharging, what will be the equation? Your equation will something like that, right? So at t equals to infinite, it will start tending towards 0. But if it was the first case, let's for example, there was some voltage or something. If it is a charging, then you can think that your equation will something like that. At t equals to infinite, your value will be having some value, correct? So you can get an idea, but exact equation if you have to calculate, I told you there is other method also, the transient, like those are also, though there you just have to use the concept and to solve. Here even you don't have much clarity of the concept. If you are just using the Laplace, that will take care of everything. Okay, so that's why many a times we use the Laplace itself, because Laplace takes care of everything. You just have to calculate the initial condition, and at t equals to greater than equals to 0 for the transient case, you just have to calculate the Laplace circuit and calculate the current or whatever you want to calculate it. Is it making sense?
Okay, sir.
Yeah. Any other doubt anybody has? Any question, in any question that you have tried solving and you got stuck? So 5.4 I have already solved all. So if you just go through the activity question, this is not that difficult. And even I told you already, there won't be any difficult questions because it's just we are just starting with the transient case. So it's like not going to ask any difficult question.
Sir, can you take one switching question of capacitor?
Okay. See, there's, let's for example, there is switching case. So I'm just taking a very random. So 100 volt is there, and then there's a switching case. You have a resistor 10 ohm, and then your capacitor. So at t equals to 0, it got connected. So there is no initial condition, right? So the question is, I'll just write it out. Okay, no, I want to give the initial condition also, because that will be more, that will clarify more. So what I can do is, in the initial condition, initially there was some charge. So there was some charge on capacitor, and that charge was q equals to 2.5 millicoulomb. Okay, something like that. And the polarity of the voltage is like this, minus or plus. Now the at t equals to 0, the switch is closed. Switch is closed. Now you have to tell me the current IT. Okay, so this is IT. How will we solve? How will we solve this equation?
We will find V by V as VC is equals to Q by C.
Correct. So you have a charge, right? So if you have a charge, then there will be some voltage also. Correct. The initial voltage. Initial
Yes,
voltage
sir.
will be what? Vc 0 minus will be what? Q of 0 minus upon C. You already have the Q charge, right? So that will be what? 2.5 into 10 to the power minus 3 upon the capacitor is what? 50 into 10 to the power minus 6. So you'll be having how much? 10 to the power 6, 3 upon 50. So this will be 10, 1 by 2. This will be 2. So this will be 50 volt. Correct? So you already have the initial voltage. So Vc of 0 plus is equals to Vc of 0 minus. You already know that it opposes the change in voltage. As the conductor was opposing the change in current, it opposes the change in voltage because it also like it's like all dependent on the energy only, half CV square, right? So this is 0 minus, this is 0 plus, or 0 plus, whatever you want to write. So this also opposes the change in energy. So if it opposes the change in energy, so this will also oppose the change in voltage. So the voltage of 0 minus and 0 plus will be same. And I already told you for any dynamic, like for a like for a inductor and for a capacitor, you need the past value. So now we have the past, like Vc of 0 minus. Okay. Now how can you write it? This equation? The Laplace, how will you write? This equation will be changed to what? This will be 10 upon S, correct? And then as you are connecting, so this will be what? 10 ohm, 10,
And capacitor and the voltage.
correct, capacitor, and then you will be having a voltage. And here, why this is minus plus? Because I already told you in the question itself, it was given the voltage across this, the charge was in such a way that the voltage is minus plus. But in the normal condition, you will be having plus minus. Correct, but as is in this question itself I gave you, it was all dependent on the polarity of the capacitor. So the polarity was already given minus plus with the charge of 2.5 like millicoulomb. Okay, so now this will be what? 10, and this will be what? 1 upon cs, right? What is that c value? C is 50 microfarad, so 50 into 10 to the power minus 6 s, and here it will be 50 upon s. So if you have to calculate the IS, 10 upon S upon 10 plus, sorry. You have to write the equation. So you can write the equation, right? So minus of, okay, here it was 100, right? So 100 upon S. So you can just write it as minus 100 upon S. Then you have plus minus, plus minus. So it will be plus IS times 10 plus IS times 1 upon 50 into 10 power minus 6s minus 50 by s equals to 0. So this is simple, right? So this will be what? Is 10 plus 1 upon 50 into 10 to the power minus 6s equals to 150 by s. Correct? And then is, you can write it as 150 by s, and this will go down, right? So this will be 10 plus 1 upon 6, what is something like that, and this is in the denominator. And if you have to calculate IT, you can take the inverse of this. Okay, this also will be in the form of some IS plus B of whatever the value, 10 plus 10 plus 6. Okay,
Okay, sir.
Yeah. Anyone has any doubt in this? You see, and the same question, if you would have solved without using Laplace, if you don't want to use Laplace, then how will you solve? Then you have to take the condition of t of 0, t equals to 0 plus. See, and what happens in the inductor? I'm not. I don't want to confuse you, but if you want to use the transient case, like you don't want to use the Laplace, so at t equals to 0 plus, what would have happened? You would have directly changed the capacitor to a voltage source. Like in the inductor at 0 plus, you are changing into a like inductor to a current source. Here you will directly change to a potential, like a voltage source. Why are you doing that? Because you already know that, right? It has stored in the form of some charge, like a voltage is already there, so you can directly at 0 plus, at just after that, like switching case, you can directly convert, like it will start working as a voltage source, right? So that's why you can directly change it to the voltage source. So but that will be taken care if you are using the Laplace method. Is it clear to everyone?
Yes, sir.
Anybody has any doubt in this? So week to week we have already. So there is nothing much. Only the Laplace thing you should be knowing, and the initial condition, a steady state, and the transient case. So steady state you should be knowing at 0 minus and infinite. Both are the steady state. Okay. And if you have to find, like your circuit will mostly will be having one inductor and one capacitor. For an inductor, you all at steady state you already know that you convert that inductor to a short circuit, right? Because the voltage across that will become zero, and for a capacitor it will change to an open circuit. So at steady state you have to calculate the current, because when you are transforming to a Laplace, right, you need that initial condition, right, initial current or initial voltage across the capacitor, right, to at least convert the electric circuit that is in the time domain to a S domain. If you are able to calculate that in the S domain, then your work is easy. Now from there, you will directly calculate the Laplace transform, take the inverse, and you'll get the all values. But the only difficult thing is, and if you don't have the initial condition, if you are seeing that at t equals to 0 minus, there is no current or voltage across the capacitor, then it's pretty simple. You don't have to do anything. You can directly convert that time domain to S domain and do your work. Yeah, anyone has any doubt? So any doubt from the 50 that you have? So this is not going to be coming in the quiz paper, but it's like let's see what happens from sixth week. We'll be directly switching toward the PNN junction, right? So this topics, if you have a doubt, you should be asking, like in the coming, go through the lectures, and you can ask now itself, because again we'll start with the week 6, and then from there it will be totally different. Like we'll be starting with the PNN junction, and then we'll discuss about the diode, clipper, clamper circuit, and then BJT, MOSFET. So this transient case will not be coming again. So like at least for this course. Anybody has any doubt in this? No?
No, sir.
So on the discourse there are some question. I answered some, but I tried to answer now itself. Like mostly you were having the doubt from the transient case only, right? Okay. Okay, then if you don't have any doubts, anything, so we'll just close it off. It's like, are you able to understand it, or like, is it giving you an idea about solving, how to solve the problems or not? So, are you getting stuck? Like, I guess week 5 you got stuck. That is what I can feel from the response side. But maybe after the quiz again, we'll come and solve some of the problems from week 5, because this is not going to be coming in the quiz paper. So, but because next week will just be again going towards the week 1 to 4, will solving some of the problem that will help you in the quiz paper. But as the quiz one will get ended, will end, we'll try solving again. Come to the transient at least 1 or 2 more session, so that by that time maybe you guys have not gone through the lectures. So if you will just go through the lectures, we will try to have 1 2 more sessions on this. Okay. Okay, yeah, Swastika. Yeah, so we'll have sessions again after the quiz for week 5. But as of now, as your deadline is uh, 16th or 19th, I guess, at least what are the concepts? Those are the very basic questions. Solve it, like try to solving it and submit the assignment. What are the doubts that you're facing? Again, will come after the quiz paper. First 2 sessions that I'll be taking will be on transient only, and then we'll switch to PN junction. Okay, yeah, 19th, right? So you have to solve it like before that, because we'll be going through again week 1 to 4 solving some questions, so that will help you in the quiz paper. And again after 23rd, at least 1 2 session if we will just take to solve transient case, and that will suffice, I guess. Okay, the basic properties of the inductor and the capacitor you should be knowing, then it will be very simple to solve. Okay, or the steady state initial condition, what happens at 0 minus 0 plus and 0. I tried to do that today. That will be sufficient for inductor and for the capacitor, how it opposes the energy change, and that's why there will be some current. If there is some, it will be having some current or some voltage if this is a capacitor. Okay, so okay, then we'll meet again, I guess. We'll be having some 2 3 sessions before the quiz paper. Just deal with week 1 to 4. So if you have any doubt from week 1 to 4, you can just come up with your doubts. What are the problem that you're facing issue? Okay. And I already told you most of the questions are NAT, so you have to solve it and write the answer. That is itself a difficult. NAT is mostly a difficult questions only, but we try to put in as like moderate question as possible. But as it is a NAT numerical answer type, if you do any calculation error, directly you'll be getting like, you'll be like doing the mistake. So there are some MCQ also, like MCQ, I mean some statement based question, whether it's a true or false. Some 10 questions are there, so some clarity of the concept also you should be needing to at least judge that whether these are true or false. And the remaining paper will be the whole NAT. So from the Thevenin, I already told you Thevenin and all is will be having a good number of questions. That is a paragraph itself, 4 5 questions on the Thevenin itself. So those are the portion that you should be knowing nicely. Laplace, very basic questions will be there. At least you should be knowing just the Laplace thing. Whether if it's a exponential, what will be the Laplace for a delta function, for a unit step function. Those things will be knowing, and that'll be more than enough. Okay, then I'll just drop it off. We'll meet again. Yeah, from not from the properties for the Laplace. Yeah, like only the very basics, like Laplace of if any equation is in the form of let's for example 1/s times s plus 4. So at least you should be knowing how to split that and write the Laplace for those cases. So those things is expected. Yeah, not very difficult question from the Laplace. Okay, and similar problem I'll solve it. Maybe when we have 2 3 sessions in the coming week, we'll solve the similar type of questions from the Laplace also. That will also give you an idea. But there won't be any transient or any this initial final case. These all things won't be there. Okay, then I'll just drop it off. I'll just stop the recording, and we'll meet again in the next week. Okay, so you can come up here all your doubts that were whatever you have from week 1 to 4. Okay, thank
Okay,
you.